Welcome to OCHEM 1. On those papers in front of you, I've asked you to list a couple of things you're excited about for coming into OCHEM, a couple of things you're anxious about for coming into OCHEM. I feel like you should be able to come up with at least a couple of things for both of those. I want to introduce myself to you guys, have you guys get to know me a little bit, because we're going to be spending a lot of time together. I also want to have some time today for you guys to get to know each other, because you'll be spending a lot of time with each other this semester, hopefully. And then in our next class period, I'd like to take a little bit more time for you all to introduce yourself to me. I'm busy right now working on learning your faces. And if I'm honest, if I try learning your names and your faces on the first day, I just usually can't. So if you'll give me today to not memorize your names, I promise you I'll do better on Wednesday. Does that sound like a good deal? Does that sound okay? Okay. All right, so a little bit about me. I am originally from Wisconsin. I grew up in a very small town. I went to a private school in the town over, where I went to a very small private school. I come from a big family. I've got 7 brothers and sisters. I fall number 6 in the line of 8. I have 6 graduating classmates from high school. So I actually have, that's my fun fact, I have more siblings than I have graduating classmates from high school. When I was in high school, I didn't get to pick my classes. It was such a small school that they only had enough teachers to teach the classes they needed to teach, so we just got assigned to our classes on the first day of school. My senior year, I took chemistry. And I wouldn't say I loved it, but it was interesting. I had a classmate who kind of made the class a competition with me. We were always trying to see who could score the highest on the exams. But if I'm being honest, I didn't understand most of what I was learning. It didn't really feel like it had a context. It was interesting. It was engaging. It just didn't feel like real life. I went to college at the University of Wisconsin-Stevens Point. It's a small state school in Wisconsin, one of the smallest ones. And I was a business major when I started college because I had a family business back home, and I thought I'd just gain some education on how to run a business and then go back home and take over the family business. My friends told me to take some chemistry classes since I liked it in high school, and so I tried, but because I wasn't a chemistry major, I wasn't allowed to take general chemistry. They put me in chemistry for the citizen, which is like a non-majors science class. I was in there with like elementary education majors, psychology majors. I found myself hating the class. It was just so boring and slow, and everything I had learned in high school chemistry was way harder than what we were talking about in this class. So I made some friends in the class and I told them, I hate this class. And they said, me too, it's too hard. I was like, this is too hard for you? We're not learning anything. So they told me I should probably study more chemistry. If this is something that engages me in a way that makes me want to go on and learn more about it, I probably shouldn't be studying business and I should be studying chemistry. So I got a chemistry minor for a semester until I realized that all of my business classes were really boring and my chemistry classes were really engaging. So the next semester I switched to a chemistry major and a business minor. And then I think by the end of my second year, I dropped business altogether. I still didn't see the real world connection to chemistry. I was very much in love with the challenge of chemistry and unaware of the application of chemistry. I had set my eyes on being a chemistry professor. I loved what I saw my professors doing, and I said, I could do that. I'm going to do that. And I'd only seen a chemistry professor with a PhD. So I set my sights on getting a PhD in chemistry so that I could go and teach chemistry. And I got into a PhD program at the University of Colorado Boulder. I loved my first year of my PhD. It was all classes. And so everything I loved about undergrad was even better in grad school because it was even more challenging, even more applicable. And then I got into my second year of grad school, which is all research, which is what the rest of grad school is. It turns out I didn't like doing research. I couldn't have had a better research advisor. I couldn't have had a more interesting research topic. My heart just wasn't in it. There were no students to interact with. There was no real learning to be done, so I was bored most of the time. And that was about the time that I learned I was able to drop out of my PhD program. The work that I had done with classes and with research had earned me a master's, which is not a part of the program, but granted that I was leaving, they felt like they could award me a master's degree. And with my master's, I was able to come and teach at a community college like this, which is actually, I didn't know this because I'd never been to a community college. This is what I wanted, was a community college. No research responsibilities, all teaching focus. So my job is you and your learning. And I'm not distracted by other ventures that interest me more. You are the most interesting thing to me. Like, you know. So I'm doing what I love. I am exactly where I thought I'd never be. And I couldn't be more excited to be here with you guys. I understand that you might not be in the same boat and that you are dreading being here taking organic chemistry. But I promise I'm going to try to make it applicable. I'm going to try to make it interesting. I'm definitely not going to try to make you fall in love with it. You can leave this class hating chemistry as much as you did when you came in. That is okay by me, because I hope you have your own passion you're pursuing. And this is just one of the hurdles on your way to getting to do what you want to do. I'm trying to make your dreams become possible, just like my dreams became possible. So raise of hands, how many of you are pre-medical, going on to med school, hopefully? Good number of hands. Pre-PA, going on to PA school. Cool, about the same. Pre-pharmacy, few hands. Engineers, couple. Chemists, right, exactly. I'll be honest, I don't teach this class for chemists. So the chemists that usually come in feel a little bit bored. But that's, like you guys just saw, this is not a class that, at Slick, this is not a class that, what am I trying to say? There aren't a lot of chemistry majors that take this class at Slick. It's often a lot of people that are going in every other direction. So not everybody raised their hand. Anybody willing to share what their career path is if it wasn't one of those mentioned?
Dental school.
Dentistry. How many dentists? Pre-dental. That's a good number. Yeah, I forgot that one. Thank you. Anything else?
Botany.
Botany. So is this a requirement for you, or is it an elective?
Oh, it's a requirement.
Yeah? And OCHEM too?
Not OCHEM too.
Good. So just an introduction, the fundamentals. I mean, what is biology if not applied chemistry? What is medicine if not applied chemistry? What is engineering if not applied chemistry? Actually, they call chemistry the central science because you can't study anything in science unless you're studying chemistry. Math, arguably not a science, and you don't need to study chemistry to study math. Not to say that math is not valuable, incredibly valuable, just arguably not necessarily a science. Okay, so I started here about 5 years ago. At the end of spring 2021, I got my master's degree, and I started teaching here in the labs summer of 2021. It was spring 2022, no, summer of 2022 that I had my first lecture for OCHEM 1. And then I didn't have OCHEM 1 the fall of 2022, but since the spring of 2023, spring, summer, fall, 23, 24, 25, I've taught OCHEM 1. So this is my 10th semester straight teaching OCHEM 1. And so I'm going to do my best to make sure that I'm teaching it to you for the first time, even though it's my 10th time in a row teaching it. You guys know how when you do the same thing over and over, it starts to just get really monotonous and you forget the fundamentals, you forget to explain why things are important. That's what I'm going to try not to do. That's my challenge this semester, is to make it make sense. Okay, so a little bit more about me. This is my partner on the left. I met him summer of 2023. We got engaged last summer, and we're getting married this summer. These are our 3 beautiful cats. It looks like they get along, doesn't it? They don't. They hate each other. We just woke up Sunday morning to the biggest fight of the year. The cat on the left is my partner's original cat. The cat on the right is my original cat, and the cat in the middle is our shared adopted cat. We got him together. So this is Yasmina, Lasuli, and Sky. On the right is my big family. We actually have a few people missing here. One of my brothers lives in Thailand. He's not shown. Another one of my brothers and his wife and his 3 kids are not here. Otherwise, these are my siblings, their spouses, and their kids. So 3 cats, to me, that's a small family. What I'd like you guys to do right now that you've gotten to know me a little bit, first, does everybody have a sheet of paper? Put your name on there so you don't forget. I want to make sure that I get all of your names. And then I want you guys to introduce yourselves to each other. Maybe share those ideas of things that make you excited about taking OCHEM and things that make you worried about taking OCHEM. One thing I want you to collaborate on is this concept map. No more than 5 things that you think are related to organic chemistry, and connect them. Sorry, I should have given maybe a little bit of an example. You're going to start by putting organic chemistry, or OCHEM, right in the middle. And then I want you to try and show 5 things that you think are related to OCHEM. If they're related to each other as well, you can connect them to each other. But make this collaborative. You know what's important to be able to collaborate? You need to know each other. So introduce yourselves. Get to know one another. We're going to spend 8 minutes on this. So you have time to get to know each other and to talk and to collaborate. I want to come around and just see how things are going as you do that. Does that sound good? If you don't break yourselves into groups, guess who's going to do it? Me. So take some time now to move around, get to know the people around you. Groups of 2, 3, 4, 5, whatever you want to do. Have at it.
Yeah, you told me. Free radical, whatever. But like, it's a good year, but it was the first time that you're not interacting.
What's your name?
Jude. I was in your Gen Chem 1.
That's
I think
right.
like in the spring? Last
Yeah.
one? Yeah.
I knew I recognized you.
Yeah.
Good to have you back.
Like all the prereqs, like summer, fall, and now here for OChem.
Good.
And OChem 2 in the summer.
Good.
Yeah.
You know what's faster in the summer?
Yeah.
Okay. Doable for sure.
I think so. I forget what I took in last summer, but it's like 2 weeks shorter.
Yeah.
It's like everything is like first day of class, no breaks.
And it's good not to take too many classes in the summer.
Yeah.
You know, to have fewer classes means more time to focus on the content from those classes because it does go fast.
I think so. Especially with the lab being like 4 hours. Can't really fit anything else.
Yeah. The labs are 4 hours during the spring and fall too.
Yeah.
They're really long. Yeah. What was your name?
Zainab.
Zainab. Nice to meet you. I love your ring. Does it tell time?
Yeah, it's real.
Sure enough. That's incredible. Save space, still functional.
I also put like reactions, acid and base.
My brain is so good now. That's so good.
How you guys doing? Feel like you did it all?
Yeah.
Came up with as much as you could? Oh, you still got one?
Yeah.
You think you got more in there that you can come up with?
I want to be a pediatrician. So I understand a little bit, but they're kids. Are we all? A lot of us. Yeah. I support the lifelong learning. Because personally, I don't want to evolve for myself.
All right. Thank you guys. I'm curious to hear what you came up with. So if we have some brave volunteers from the class, to share some of the concepts that they think are related to organic chemistry.
Carbon.
Carbon. Yeah, let's put that front and center. Why would you think carbon is related to organic chemistry?
Most organic matter is made out of carbon, so I'm like, it's pretty basic.
The definition of organic chemistry. Does anybody know? Definition of organic chemistry? You know, there's two fields, organic and inorganic, which is kind of sad. Inorganic got named as the leftovers. Some people refer to things that are inorganic as minerals, which is actually not a bad way to think of it, although some minerals can have organic components. Organic chemistry is the study of hydrocarbons and their derivatives. And we'll be dealing with mostly the derivatives and not very much the hydrocarbons. Hydrocarbons would be things like the octane that you burn in your car, the butane that you burn on your grill, or the propane. Those of you in lab this semester? Sorry, that's me telling you to raise your hand if you are. Good number of us, okay, probably more than half. You'll be dealing with hexane from time to time. Hexane is also a hydrocarbon. But in terms of the rest of organic chemistry, hydrocarbons are like the smallest part of organic structures. They're just the simplest form of organic structures. So derivatives would include things like oxygen-containing hydrocarbon chains, nitrogen-containing, sulfur-containing, all of that stuff. Thank you. And your name?
I'm Salem.
Salem. Thank you. All right, who else has got a topic? Chemical structures. Rachel?
Yes.
Good. Now, could you use chemical structures outside of organic chemistry? Yeah, definitely. Every chemical's got a chemical structure. But in organic chemistry especially, the chemical structure is very important. The way that it takes up three-dimensional space is crucial to the way that it interacts with other things that take up three-dimensional space in our bodies. So we'll be talking about the structure in depth for all of our different chemicals. Great. What else?
Reactions.
Thank you. Reactions. You learn about reactions a lot in Gen Chem. Some of them involve organic molecules. Most of them are inorganic reactions. We'll be dealing with a lot of reactions. This is about the second half of our course is on reactions. We're going to spend the first half of our course learning about those hydrocarbon derivatives and their structures, among other things. And then we'll learn more about the reactions they go through. What else? That was it. We got three things.
Electronegativity.
Electronegativity. What's your name?
Annie.
Annie. Do you guys know why I like to abbreviate it as EN? Because electronegativity is such a long word. Nobody likes to spell it all the way out. I think electronegativity very well could play a bigger role in OChem than it does in general chemistry. And it, in a lot of ways, is connected to our chemical structures. The way that you read and interpret a chemical structure relies a lot on the electronegativity of the atoms inside of that structure, the way that they're bonded. Thank you. Can I get one more?
Functional groups.
Functional groups. And your name?
Jordan.
Jordan. I'm going to abbreviate functional groups as FG. And we'll talk about functional groups throughout most of the semester. It'll be the way that we actually start Unit 2. So we're going to get through all of Unit 1, which is pretty much a review of general chemistry, before we come back to talk about functional groups specifically. But then the rest of OChem 1 and all of OChem 2 is talking about what are these different groups doing? What are their functions? And predominantly, what are their functions in the reactions? And functional groups very much, I don't know, maybe I don't want to show a connection between electronegativity and functional group. There doesn't need to be a relationship there, but strong correlation for sure between the functional groups and the electronegativity of those atoms, the way that that all coordinates into the reactions. Cool. Can I get anybody that's willing to share something that you are excited about in taking OChem this semester? Maybe a new hand that we haven't seen yet?
I just love learning how and why things work.
How and why things work. Great. You know what? How and why things work is often called the mechanism. I didn't share this, but I grew up a mechanic's son. So I worked in a mechanic shop all through high school and during the summers in college. And mechanics are named after the mechanism of the cars that they fix, right? So there is a lot of background that I had in learning about how things work that feeds well into organic chemistry. But I do want you to have that kind of perspective. An organic chemist is a bit like the mechanic of molecules, organic molecules. So we will be learning a lot about how and why things work. How and why things work. Anybody will? Oh, and your name? Brenna. Thank you. Anybody willing to share what they're worried about this semester? The final exam? You only have 2 exams, midterm and final. Well, that's fair. When we get to the exams, I'll actually talk to you guys a bit about test-taking strategies. We're going to be working on how to use different tools that you'll have at your advantage during the exams. For instance, I like to give my students this tool on all of their exams. These are called correlation tables, and we'll talk about it in Unit 3. This is an incredibly useful tool. In the same way that like a dictionary is a useful tool or a thesaurus is a useful tool, this is a useful tool for interpreting data. But it's not useful unless you know how to use it. So we're going to learn how to use it so that you can use it well on the exam. Another tool that I talk about right before exams start is actually your breath. Your breath is the most powerful tool that you can have in any situation where you might feel nervous. And this gets me out of my depth because it gets me to start talking about biology. But your diaphragm is a... You here for OChem?
No.
Bummer. You can stick around if you'd like.
That's a next semester class. I think they must have moved my class then.
Good luck. Your diaphragm is a muscle, largely involuntary, but you can control your diaphragm. When you take a deep breath, when you control your diaphragm, you push down onto your vagus nerve, it stimulates your rest and digest state of being, which calms you. So, in those moments of high anxiety, like on an exam, you should pay attention to your breath. It's the only thing that you can control. You can't control how you studied once you get there. You can't control how I wrote the questions. You can't control anything about your body other than your breath. But by controlling your breath, by taking deep breaths, by intentionally pressing down with your diaphragm on that vagus nerve, you can actually reset your body back into a less anxious place. You can also trick yourself. Your body doesn't know the difference between being anxious and being excited. Your heart rate increases, your breath shortens, you start to get sweaty, whether you're excited or anxious. So if you recognize that you're anxious, just tell yourself you're excited. Your blood is pumping fast, so you get oxygen to your brain, so you know the answers quicker. That's what's going on. You're excited to answer those questions. That's all. So, and the periodic table is a tool that I give you. So it's fair to be anxious about exams. They are the highest stake assignment in the class. And yet, truth be told, I've seen students fail the exam and easily pass the class. This is not a class where I feel that your work throughout the semester is disqualified based on how you show up for the final. You can't control the situation that comes before going to the final. Sometimes shit hits the fan right before you come in to take the final, you know? You can't control that. So although it is high stakes, it really does get buffered out with the rest of the semester. So failing the final doesn't mean failing the class, but it does mean a hit to your grade. I will talk to you guys about another aspect of my final exam after we talk about the syllabus. Do you guys have any other questions? Or any other things you want to share about your concept map or things you're anxious about or excited about? And your name? Eric, thanks.
You didn't talk about it in class, but I was reading something about how all the OCHEM concepts build on each other. And I'm a little worried that, like, if I miss or don't understand one concept, then that will really make it hard to understand some of the later concepts.
Yeah. Well, that's a good point. All of these concepts building on each other means missing something early on, making it more difficult to do well later on. You know what? I would say that's not always true. So, what I would say is there's always opportunities later in the semester to solidify your foundational understanding from early on in the semester. It's never too late to get back to what you missed. One thing that I will try to give you guys feedback on throughout the semester, especially as we get later into the course, is what fundamental things I think you might be lacking on that you want to go back and refresh, re-solidify. So that's a valid concern, being concerned about missing something early on. But I think you'll have time to correct for it. What's your name?
Kirsten.
Kirsten, thank you. I know I said I wasn't going to learn names, but then I tried, and it's not going very well. Anything else? Okay. I would like you guys, again in those groups, to look at our syllabus and go through and try to find 3 things as a group that you either have a question on, or you're excited to see, or you didn't see. So things you might you wanted to know about the class that you're not seeing it in the syllabus, things you didn't realize were going to be a part of the class that you're excited will be, or things that you're seeing on the syllabus that you want some clarifications on. I have to admit, you guys know, I didn't publish the course until today. I'm behind. I wanted to revamp this homepage. So you guys might be seeing a new homepage on the course later on in the semester. I used to kind of keep my syllabus basically here, and then I forgot about it and I haven't updated it. So I wouldn't really go to this for the most up-to-date information. This is going to be going away. I would instead go to that simple syllabus tab that you guys have on the left-hand side of our course. If you've got a tablet or your phone or your laptop, just pull up the simple syllabus and scroll through until you see something that you like or don't like. While you do that, I'm actually going to put some information that I want to get from you. Sorry, I didn't think this through. I wanted you to keep those handouts. So I can't take them from you. I'm going to cut up some paper for you. And I'm going to put some information that I'd like from you to help me get to know you better. But it also gives me that attendance sheet, and it lets me check in and remember things about you later on in the semester. So I'm going to put up some things I want to know about you. I'm going to hand out some sheets for you to fill those in on, while you guys spend the next 5 minutes exploring the syllabus together. All right? Break.
Once those votes are on it'll exist. That's what it needs to physics. There's a lot of that's fair. Alright. Pre-reading. Yeah. If you want to start Thank you.
Mm-hmm.
Thank you, John.
You're welcome. That's for your name stuff. Oh, are those both you? I was like, I didn't see anybody leave. Yep. You're welcome. You're welcome. This one's for you. Yep. Thank you, guys. Just that info up there. Did I miss anybody with my sheet? then don't buy a molecular modeling kit.
No, literally not going to use it outside of this.
Well, you're probably not going to use it inside of this.
Really?
I don't know. It depends. Some people do. A lot of people don't.
Are they expensive?
They can be.
I know.
No, you can find some for like $20. You can find others for $80. Mine was $120, and I emailed them and I said, I'm a brand new professor. Can I get a discount? They gave it to me for $100.
Like, perfect, thank you.
And I stopped using it largely in class because I bought it for the features it had. I thought it would make for better demonstrations. It didn't. You can find free ones down at the STEM Center. I've only ever seen one student in all my years teaching who actually had it out during the exam building stuff. So I don't know. It can be a good tool, but it's not going to be the most useful investment for you. All right. Was everybody able to fill out that info for me?
There's also a scavenger.
Just a little one. I always forget about that. Okay. Let's talk about the syllabus, shall we? What do you want to know? What are you excited to see? What do you feel like was missing from there? You got one, Tanner?
Is active good? Is it like real chem?
Okay, good question. So our homework will be through active. It is different from real chem in that it's not your textbook. It's also different from real chem in that you solve each problem individually, so you don't get like a set. Let me show you active. You guys will have a introduction to active assignment that is due by the end of the week. It's short and quick. It's just meant to get you familiarized with the tools. And then your first homework assignment is due at the end of next week. And okay, so I picked a bad one. That was a multiple choice. You will be doing a lot of drawing. Well, I guess it's very possible you won't be doing drawings in the first unit. So I apologize for that. Should have picked a better one. I've chosen active as your homework assignment or as your own homework system because of its features for organic chemistry. Active was made by a chemist for chemists. So its features are good. Not amazing, but better than most. So you'll see that they have a drawing tool for drawing organic molecules, and it's this hexagonal pattern. That's because a lot of structures that we draw in organic chemistry have this zigzag. And so that hexagonal pattern sets you up for those zigzags. They allow you to insert rings, but depending on the size of the ring that you choose, it will sometimes get rid of those zigzag patterns. Or let's say that you put in a triple bond, it gets rid of the large pattern. So it takes some time to get used to, but I think it's the best of what's available out there for doing organic chemistry online. Truth be told, I didn't always have my OChem homework online. I used to write my own homework assignments and grade them myself. I stopped doing it because I found I wasn't actually giving feedback to students on homework. I was just saying right or wrong, and I was spending so much time on grading. I didn't have any time to say, this is why you did it wrong. This is what I'd like you to do differently to do better. I wasn't providing feedback on homework, so it was basically the same amount of work for you, but just more work for me. So I have offloaded my homework to active, And that's because if you get something wrong on active, it will tell you whether it's correct or incorrect. And it's not letting me zoom in, but down here on the bottom, you can see that it actually gives you some feedback. Not all of its feedback is amazing. Sometimes its feedback has nothing to do with what you've done wrong, which is probably something you've encountered with all of your online homework. So I would say if you find the feedback to be not useful, send me a screenshot of your problem and say, I'm stuck on this problem. I don't know how to get it right. Takes some getting used to, but overall I'd say it's pretty good. Homework is 25% of your grade. So you can get a C in the class if you ace everything else but don't do your homework. But I'll be honest, the homework is there to guide you and structure the learning, so you should do your homework. While we're on this, I do accept late work. You guys are adults, so I can put deadlines on things and I can close off assignments for you. But sometimes as adults, you've got other priorities that come before this class. So I'm not going to be too rigid with you about when you get things done. Your deadline here is May 11th at 5:50 p.m. That is when every assignment on active will lock. Random time? What's that time? No. That is the start of our final exam, May 11th at 5:50 p.m. in this classroom. So once you start the final, there's no point to go back and do the homework. That homework was meant to prepare you for the final. So now that you've started the final, the homework is no longer meaningful. It is a cumulative final. So I don't close any of the homework until you've taken your final. Good question.
Do you have the access code for active?
I think you may have gotten access when you registered for the class. I believe that the fee for active was embedded into the course fees. So I don't have an access code. So it's not letting you on.
I'll figure it out.
Can you send me a Canvas message? And I will reach out to my support at Active and see if they were supposed to send me an email or if I did something wrong. And I'll let you guys get access.
Will it still like show up weekly for our homework? Like it will pop up as like, this is what's due this week, even though the deadline is May 11th?
Yes, yes. So on Active, I have actually set, I have not yet set, sorry. I will set due dates for the assignments, but I will set the close date when you're allowed to take it to be that day. So it will have deadlines, and those deadlines will populate into Canvas. So it will, I do apologize, this has not been updated yet, but these will show up here. Oh, maybe these, oh no, sorry, these ones. It will show up here as that due date. It says it's done it, but I don't think that these are the right ones, so it's misleading. I'm sorry. I will have this done tomorrow morning. I meant to have it done this morning. Other things about the syllabus? What are you excited? What are you confused about?
Sorry, not what I'm excited and confused about.
That's okay.
But do you have like a preferred way to contact you? Anything, like
Yeah.
the email?
I would say focus on Canvas inbox because my Outlook email gets notifications when I get a Canvas message, but I also get 1,000 other Outlook emails every day. So if you message me on Canvas, it is a smaller pile for me to sort through, and I prioritize responding to my Canvas messages before my Outlook messages. So that's the way that I would do it. Do you know what else I haven't? Maybe I'll do this right now. This is my summer schedule on here. And I have a new schedule for you guys. So I'm going to upload that right now. And I'll show you that at the bottom of my schedule, I actually have, or at the bottom of our course schedule, I have my weekly schedule with a QR code that you can scan to set up a meeting time with me. And that goes right to my Outlook email if you don't want to message me on Canvas. So this is my weekly schedule. I have what's called course release this semester because I am building this CHEM 1250 course this semester. It's our first semester teaching it here at Slick. You're all welcome to take it. It's called Introduction to Chemical and Instrumental Analysis. Somebody's in it. Are you here? I don't know you because it's our first day. No? None of you know that you're in this? Okay, they might not have come today. CHEM 1250, that's Friday afternoons. So I have course release. So you'll notice that my mornings are very empty. Don't get it twisted. I will be very busy building material. But I do have office hours, student hours, that's dedicated to you. I'm also happy to set up time outside of this. As you can see, I do have a very flexible schedule. So if my student hours don't work for you, then you should message me on Canvas or email me. And I'm happy to set up another time outside of my student hours to meet with you about questions for the class.
On your thing you just posted, like the schedule,
Yeah.
the finals on the 4th of May. But that's just 11.
Oh, good point.
But
That's,
the finals weeks is that week. Like
yeah,
27th.
that's my fault.
Okay.
I went the week out. I forgot. Well, glad I haven't done all the assignments yet. Thanks for pointing that out.
Yeah. Also, I have another question.
Yes.
I know the textbook's optional. Do you recommend like reading it, or do you not think that's
Great question.
applicable?
Okay, so I actually don't decide the textbook for this class. Our course lead does. We have a number of other assignments, 3, that are impacted by the course lead. They're assignments that I have to do. They are assessments of the entire course, not just individual sections, but all sections of the course. So we need like bookmark assignments that everybody is doing and getting graded on so that we can see how all sections are doing. Those assignments and the textbook align better with the course lead's class and the way that he does things rather than my class. You're not required to buy it. In fact, I would not buy the new version. It's expensive. He doesn't even require his students to buy the new version, even though it's at the bookstore. You can buy an old version of the textbook because all the same information is in there. I don't assign homework problems out of the textbook. You could also use online free resources. I actually have one linked for you down here. There's a free online textbook by McMurray. It's a 10th edition textbook, which means it's been heavily vetted for 9 editions, and then he put the 10th edition online for free. So it's a good textbook, and it has control find functions. Like you can search the entire textbook for certain concepts. You have pre-reading quizzes, and those pre-reading quizzes are 10% of the grade. They are meant to be done not before you read, but they are meant to be done on the reading you do before class. So when you read before class, that's a pre-reading. You read before class.
On active, on what?
Anywhere you want. Yeah. What I would actually recommend is pulling up the pre-reading quiz and seeing what you know and what you don't, and then finding a resource like the class textbook or like the online textbook or like Google, and just finding answers to the other questions. If I'm honest, I didn't read my OCHEM textbook at all when I was in OCHEM. Not good, not good. which is why I'm incentivizing that you read yours by making it a part of your grade. But it is doable. So those pre-reading questions, the idea is that those are the baseline concepts I want you to have an idea on before you come in to learn about it in lecture. I want the pre-reading quizzes to kind of get those gears moving for you so that you can come into lecture ready to learn about these things that you just got confused about in the reading. Does that make sense? The alternative is you come to lecture, and you hear me talk about all these weird things, and you get confused, and then you go to the reading and you get a better idea. And some people actually prefer that. So pre-reading quizzes also have the same deadline because you can do those pre-reading quizzes whenever you want throughout the semester. I'll have the due dates the night before we talk about that concept in lecture so that you know where to be before we get into something in lecture. But you can turn them in whenever. So no real required textbook, no real required way to do those concepts. And most textbooks talk about the same things in the same order. So whether you're using this online textbook or the hard copy textbook or you pirate a textbook, you'll find similar information in similar places. If you ever get confused and you're really lost and you can't find something, shoot me a message and I'll point you in the right place if my wording is not clear. Okay, what else?
Are we allowed more than one attempt per homework problem on active?
Good question. So pre-reading quizzes, unlimited attempts, but you never see the right answer. So you got to keep going until you get the right attempt. On homework problems, let's check. I used to set it to like 50. I have to click manually to the number of points, so that was really hard. And then I had students that were like, I want to give up, but I can't give up. There's no button to give up. So I have to use 50 attempts to give up and see the answer. So I have changed it to be 20 attempts. That's a lot. Honestly, if you're looking to give up, that's still a lot, right? I would say don't use 20 attempts trying to get the right answer. If you're doing more than 10 attempts, you should just take a screenshot of it and send it to me and ask me what's going on. I had a student once that was like, I'm on my last attempt and I don't know what I'm doing wrong. What did you do 19 times? I don't even know all of the 19 ways you could have changed that. And do you know what it is most of the time? It's lone pairs. Active will not tell you that you need lone pairs, but it is looking for lone pairs and it marks you off for not showing the lone pairs. And the feedback has nothing to do with lone pairs. That's 9 times out of 10, that's the problem. So if you're trying and trying, don't get to 10 attempts. Get to 8 and then email me and say, I don't know what I'm doing wrong. Deal? Okay. Yes, another one.
Then does each attempt dock points?
No. Nope. If you get the right answer, you get the points. You will lose enough points on the unit tests and the exams. You don't need to lose points here. Sorry, let me phrase that a different way. This is meant to be a mastery-based experience. So I don't want you to lose points for trying. I want you to earn points for getting there. Does that make sense?
So do you curve the class?
If I need to.
Okay.
I don't always need to. And what does need mean? So obviously, like the average in an ideal situation would be a 75%. We technically are not usually an ideal situation. I think in statistics, you need at least 30 data pieces to be able to look for normal distribution. And our classes are usually less than 30. So we don't normally see a normal distribution. In fact, we have a unique demographic. A raise of hands of how many of you already have degrees in this classroom. What is that, half the class? Not a normal demographic of college students, right? So At the end of the semester, grades typically look like this. There's a lot of students doing really well and a lot of students not doing really well, and I give very few Bs. I give a lot of A's and a lot of C's, D's, and E's. So this is what they call a U-shaped distribution. It's usually an indicator of bad data, unless you know that your data is an abnormal demographic compared to other institutions. So that's what we have. I'm not looking for a normal distribution, but I do still look to see that that U is dipped at the 75%. I do the same for my midterm and my final. If they are less than a 70%, I will curve them to a 75. If they're between 70 and 75, I don't usually. The midterm is often above a 75%, and the final is usually around a 75%, and the class itself is not usually lower than a 75. So I don't do a lot of curving, but sometimes I do, and I'll email you guys if I do. Actually, one thing that I will do at the end of the semester is I will reevaluate our grading scale. You guys know the standard grading scale, 100 to 93, 93 to 90, blah, blah, blah. That works really well when you've got a large number of students. You often see really good pockets in those grades. I usually don't see good pockets in my grades. I'll see like the last student ends at 94, and then I have a student at 90, 89, and 88. So do you really think I should give just one A minus, and those other two students should get a B plus? No, that's like one packet of scores. So then I drop the A minus to go down to 88. I look for normal breaks in the grades to look for my grading scale. Sometimes it works out nice and I'm able to just keep what it is. A lot of times it actually impacts the people on the lower end more. I end up spreading the bottom of the class, which is kind of like a curve for the people that need it. Good question. All right, I want to talk about the other major parts of your course, which are the unit tests. And I heard you guys had some questions about this. Somewhat. I heard somebody had questions about the unit tests. And you had good questions. Do you want to ask it? Yes.
So it says it's in 2 parts.
Yes.
And part A is 60 minutes and it's multiple choice, and part B is 60 minutes and it's short answer. Are they 2 separate halves, or are they together and you have to take them all in one sitting? And if so, well, yeah.
Great question. So first, I always forget this. It is 35% of the grade. 2 parts. Part A, often 10 multiple choice questions. And you get 2 attempts at part A. Mastery. I'm looking to see that you can figure out what you did wrong on part A on those multiple choice problems, study up on those concepts, and take another attempt to do well. Part B is short answer, 1 attempt. This is usually 1 to 3 problems. Since it's short answer and it's organic chemistry, you'll have to write it out. You're going to have to do some drawing and then take a picture of it and upload it into the Canvas quiz. 60 minutes for both attempts of part A, 60 minutes for part B. You could, in theory, spend 3 hours doing this. In terms of timeline, I give you an entire weekend to do a unit test. So on our schedule, unit tests are in blue. We had an interesting one where our second unit test falls over President's Day. Now, why would I make you finish it Sunday night if we're not going to meet again until Wednesday? I might give you all the way through that Tuesday night to take unit test 2. A little bit longer. It's not going to change your score usually, but it gives you a little bit more time to work on it. So you don't need to do them all in one sitting. What I recommend is taking part A early, figuring out what you're good on and what you're not good on, studying up on the things you need help with. coming back a day or two later and taking your second attempt at part A, and then later coming back and doing part B, which is why it is second. I want this to be the last part of the unit test you do so that you have all of the strength that you got from part A. It's not the same questions both times you take part A. I have learning objectives that I want you guys to hit, and those learning objectives have question banks with multiple questions in them. So it is unlikely that any of you will have the exact same part A. You'll have different combinations of the different question bank options. And when you take your second attempt, it will truly be a mastery-based assessment. Do you understand the same concept now that you're seeing a new problem with it? Sometimes you get the same problem. I can't control it, but usually it's a different question.
I had another question with that.
Yes.
So they're through Canvas and you can take them at home. Do you need to have like lockdown browser or?
Do you want lockdown browser?
No.
Yeah.
Not saying that.
I hate lockdown browser.
I think that's kind of silly.
I think it incentivizes cheating in a way sometimes. I think a lot of forms of prohibition incentivize getting around that. I'm already encouraging that you guys take the unit tests with your notes. I would encourage that you don't use external resources that you won't have when you take the midterm and the final. Use the unit test as a snapshot of how you'll do on the exams, which is the last part that I'll put up here. The exams are also 35% of your grade. You have the midterm. On the midterm, you get one side of a sheet of paper as a cheat sheet. This needs to be handwritten. I won't let you come in with printed material on it, mainly because any of your classmates that go to the testing center, what I've heard is that you're not allowed handwritten stuff. So this is kind of an equalizer. Everybody's got to write their cheat sheet with their hand. I know a lot of you will take notes on your tablets. That does not mean writing it on your tablet and printing it out. It means pen to paper for your cheat sheet. One side for the midterm, two sides for the final. The final is cumulative, so some people like to save their cheat sheet from the midterm and then just add another sheet for the final. I would recommend revising your cheat sheet more than once before you ever even get to the midterm. So when you're ready to take unit test 1, build a mini cheat sheet for that unit test. Have that with you and your notes while you take the unit test. When you get to unit test 2, build a mini cheat sheet of unit 2. Have that and your notes with you as you prepare for that unit test. When you get to the midterm, you now have mini cheat sheets of each of the units that you can revise and reformulate into a new cheat sheet for the midterm. Do the same thing for the final. So no lockdown browser. Take it anywhere you want. Just don't be late because it cuts you off at midnight. I can't tell you how many times students start their test at like 11:10, and then I can see that they got cut off at midnight because they ran out of time to take it. I'm giving you this schedule now. This is on our homepage. It will automatically expand when you open our homepage. Put these dates in your schedule. Plan for it. How many of you are only taking this class this semester? Wow, good for you. And by that I mean not working, not involved with, don't have a life, no friends or family. Oh, right, okay, you're all people. So plan for these major assignments because they're set and they're really hard to move. And it's better if you can plan how your semester is going to go with these assignments in mind.
Sorry, you might have said this. How many of them are there for the unit test?
Good question. There's 5. 5 units, 5 unit tests. 3 in the first half, 2 in the second half, And you can see those 2 in the second half are bigger units. The idea is to have more in the beginning to kind of hit you harder early on so that you know what you're going to need to study, how to study to get you prepared more. Less in the second half so that you have more time to just work with those skills you developed in the first half. Yeah? Okay. And by the way, I am happy to talk about making accommodations for whatever you need. Just reach out, send me a message. If I can't accommodate it, then that's what I'll say. But if I can, I'll try to. All right, what else? Cheat sheet. I'm the only one in the department that offers it. Everybody else says that I'm hurting you by giving you a cheat sheet. So I'm going to say this right now. Cheat sheets are not an advantage. It's not me helping you. It's not me throwing you a bone. They are the biggest risk that I put into my class every semester. It's me risking your grade and your learning. However, a lot of you will have entrance exams that test on organic chemistry, and I think a cheat sheet is basically like the Cliff Notes of organic chemistry. I'm not going to make you make a cheat sheet, which is why it's not a required assignment. But if you want to make a Cliff Notes of all the most important things from OCHEM, go for it. Think of it as a tool, and know that if you have a sloppy tool, it's going to hurt you on the exam. If you have a really solid tool and you know how to use your tool, it's going to really benefit you on the exam. The best cheat sheet for an exam is the one you never have to look at. When I was taking biochem in college, my professor allowed cheat sheets, and I asked him why. This is the hardest class. Why are you letting us have a cheat sheet? He said it didn't actually change his exam averages at all. Students that made the cheat sheet the day of did really poorly on the exams, and they spent the whole time looking at their sheet. Students that revised their cheat sheet more than once never looked at it, never needed to look at it. They knew it all because they'd spent all that time revising it. So if you want to have a good cheat sheet, revise, revise, revise. Then you won't need it because you'll know it. I'm going to give cheat sheets as long as I can until the department tells me I can't. I can't in my Gen Chem classes anymore because I'm not the course lead for that. I'm not the course lead for this either, but our course lead isn't twisting my arm on it. So I'll give you guys a cheat sheet as long as I can, but know that I'm not giving you an advantage. I'm risking your learning. I'm putting it in your brain, so they say, that you don't need to know any of this stuff. You can just put it on there and whatever, when you get to the exam, it won't be that hard. You'll have an example. You can look at it. It will be that hard. The cheat sheet is a tool to help you leverage the knowledge you know. But the best use of it is knowing it well in advance. Anything else? There's another set of assignments that are called analysis of an organic compound. And this assignment used to be a bonus assignment in my class until I heard from enough students that it was so rewarding and gave such a good perspective that I decided to make it a required component. We're going to spread it out throughout the entire semester. So by next week, Wednesday, I want you to submit the assignment, but I want you to come to class with an organic compound in mind. An organic compound that is relevant to you. So if you're going into medicine, think about something you work with or might work with a lot. If you're in dentistry, if you're in pharmacy, if you do a lot of baking, whatever you want, find an interest, find an organic molecule that's in that interest. We're going to study it all semester. There are some requirements that you don't know how to interpret yet, but I do. and that is involving the reactions of those molecules. I'm going to have you show how to do a reaction on that molecule by the end of the semester. But that means it needs to be a molecule with a functional group that you are learning how to do a reaction on. So if you submit a compound but it doesn't work with our chemistry, I'm just going to say no, submit another one. If you want to submit 3 and prioritize them, then I will say no, yes, no, or whatever, and might make it easier for you. I love this assignment. I said I'm going to try and make this applicable for you. I can show you molecules all day, all semester, and I will. But you picked this one. That's going to make it more applicable to you than I can ever make it. I really like that assignment. It goes along with all of the things that we learn throughout the semester, so it's really useful for us. It is a mastery-based assignment, meaning no points until you get full points. Right now they're set out of 1 point each, but I think I'm going to be changing that to be 2 points each to make them a little bit higher stakes. I have some students that just don't do them. The thing is, if you don't do them, it's like not doing a part B of your unit tests, which is a mid-stake assessment category. So I want you to do them. I want you to be involved. No late points on them, but when you stay on top of them, you'll see that they rope in with what we're learning about in class. Okay. Anything else that you guys would like to talk about?
I was just curious about at the bottom of the syllabus, it says that there were some mistakes on some of the compounds.
Mm-hmm.
Which ones are they?
Well, that's for you to find out, isn't it? That's a good question. I give extra credit for learning that I can see. So I assess your learning to give extra credit. I don't give extra credit for going to events or being involved with clubs or just turning something in. I will grade everything if I'm going to give you extra credit on it. I want you to come back to this later in the semester.
I think that I found some of them, but I just don't know. Maybe I'll ask you later.
Good.
I'll show you.
Good answer.
And
So some of the bonus points that you can earn this semester. I was mentioning these course-wide assignments that all sections have to implement so that we can track how everybody is learning certain concepts. Those are called PLOs, Program Learning Outcomes. Those are assignments made by the course lead, so they look nothing like my material, and you won't be tested on anything that looks like this, but they are extra credit to the homework category. But it is learning based, right? So I will go through and see how well you actually did and give you extra credit based on how well you did. And I like to go through and like annotate. I'll give like a little list of the points you earned. I also will upload my previous semester's. I really got to fix this. I guess something didn't go well with my my course import. How many of you have submitted an assignment already? Has anybody? Have you? I might have to re-import this course. I think that it imported the wrong materials. I'm going to upload last fall's midterm and final exam so that you can use that to study as you prepare for your midterm and final exam. I'll give you a hint of what the spring exam looked like last year. I have bonus questions in the exams. Oftentimes, these bonus questions go back to a question that you just learned about. So there's some usefulness there. They tie in with each other. The only other bonus opportunity is that after the midterm exam, I like to offer a midterm exam analysis. Again, It's not just earning points back for submitting it. I go through and I tell you whether you are getting those points back or not. But you can earn up to half of the points you lost from the midterm exam. Here's the deal. The bonus questions on the midterm always go to the students that score higher on the midterm. So it's disproportionate that those bonus points help students. It disproportionately helps students that already did well. And it does not help students who did not do well. The midterm exam analysis, given that it gives you half of your points back, up to half of your points back, disproportionately helps people that do poorly on the midterm exam. So if you did really well, you might only be able to earn 2 points back for the midterm. If you did really poorly, you might be able to earn 20 points back for the midterm. So I offer both of them as ways to kind of balance out the bonus points. Additionally, the midterm analysis, it helps you identify the concepts you missed, understand them better, learn them before you come back for the final and see them again. So it's useful for anybody to complete. It's especially useful for people that did poorly on the midterm. Those are the bonus opportunities. Yep. I forgot to mention this. I don't usually like to go through the whole 2-hour period because it's long and I talk a lot. So each week in class, I like to give a 5-minute break for you guys to stand up and move around. Usually I'll do that about halfway through. I think maybe now's a good time because I still want to talk a little bit more. So why don't you guys take 5 minutes to just get up, move around, find the bathrooms and the water fountains. And then when we come back in, I want to talk about fundamental forces before we head out today. Yeah?
Would this be like an okay compound to use? Are you looking for more?
No. It's not more. This is a great compound
Okay.
in general. It's the chemistry. So what you've got are amide polymers. And we don't do much with amides in OCHEM 1. If this were OCHEM 2, done deal. Are you coming to my OCHEM 2?
I'm not.
Oh. The problem is the reactions. You won't have a reaction that really goes with it. But if you're willing to work with me individually, I can help navigate you towards reactions we'll learn about that could apply here, but we're not going to talk about how they apply here, so that you can do this. Okay. But if you come up with another one, there might be better.
I had a question. So was that one of them?
No.
Written
Oh.
incorrectly?
Yeah, it might be. I forgot actually. It's been a while.
So it's like, that one is written incorrectly,
The subscript
right?
is in the wrong spot.
Yeah.
Who did that?
I don't know. But also, I've never seen a molecule that looks like that. Is that normal?
We're going to talk about it this semester.
Okay.
Yep. When it comes to structure.
Okay.
What
So
you're
it's like
actually,
maybe-
what you're seeing is you're looking at a molecule from its side rather than from above it or below it. So you're not looking straight down on this molecule. If you did, it would
which
look
is
like
why-
this.
Okay.
You're
I
actually
think I
looking at
see
it from its side.
Okay. So you've got the bump, and then these are the connectors, and this is the others, right?
Yeah.
Okay.
Yeah. It's got this kind of like
Uh-huh.
bumpy structure to it. Yep.
Okay.
What about the other one?
Oh gosh, I don't know. That was my question.
Ah.
Is that was one of them?
So I actually
But then-
forgot if this one is or not, but I think it might be.
Okay. Are they all right here?
Nope.
Okay, I didn't think so because there are more down here. But I was looking through and I was like, I don't know enough about structure and everything, and so I was counting the molecules and trying to find where they might be wrong. Is it like the shape of them? Is it that some of them are missing things? Is it that
Man, it's been so long since I wrote that little thing in there that I Forgot. What is this silly little message? Thank you for reading the
Oh.
syllabus.
It said,
It gives that to you every time?
that I read the syllabus. And
You had to click
I
it?
had to click acknowledge.
Do you all have to do that?
I mean, you don't have to.
That's
but,
wild.
Like, you kind of have to. I mean, it's right there.
You know, I used to make my own syllabi. Like on a Word doc, I had like colors, boxes. And now they made me do this. This is not simpler for me.
Yeah.
I forget what it is. I don't think it's in that diagram.
No. Are you saying I can't use like any polymers?
No, it's not that you can't use any polymers.
Just not the ones I pick.
A lot of the polymers that you're seeing are good for OCHEM 2. But again, either of these polymers, oh, actually this one, no. Sorry. Because it uses phthalate as a,
I'll keep looking. I'm gonna give you like a list of 3 and you're gonna be like, no, no, no.
I've had students use polymers in the past.
Also, the homework thing was just, I was being silly. It works.
Oh, good. Because I didn't want to have to deal with that. But I was going to.
Polyvinyl chloride?
No, oh, and that one because it needs to have,
Oh, there's only one.
yeah.
Other than carbon and hydrogen. Okay. Well, that was my 3. You already said no to.
Well, then I'd go with nylon, and we can
I can look.
make it work.
I don't want to force this. I'm already not good at chemistry.
Okay.
And there's no
This
chemistry
is so
between me and
weird.
this right now.
Okay, sorry, once again, raise the hands. How many people have done something on our Canvas? So you guys wouldn't be mad if I reset it.
You better do it soon.
Okay, I know. I'm gonna do it right now. Because I don't know what it did, but it did not import what I wanted it to import. Oh, it's gonna be fine. We'll figure it out. Listen, they did all of this before, like, technology. They taught organic chemistry before technology, so we can do it again if we need to. Yes. That one will definitely talk about those structures, or those functional groups. Is that a polymer? Sugar?
It's a, I don't know what it is, sodium alginate.
Oh, I don't know.
It's used in hydrogels.
Hydrogens.
Hydrogels.
Hydrogels. That makes sense. Yes? Good question. I don't do a lot of PowerPoint slides. I do a lot of board work. The handout I gave you guys today, I'm going to try to bring similar types of handouts. Maybe not each week, but each time I need to. So I would recommend taking notes in one of 2 ways. Having a notebook or some sort of online notebook is useful for the notes that I put on the board because I'm going to put a lot of notes on the board. And I'm thoughtful about the way I put notes on the board because I'm intending for it to stay with you forever. So I don't need you to interpret how I'm putting it on and like reformat it for a way that works for you. I'm trying to do that already. So I'd have a notebook or some way to take notes from the board, and then also having the worksheets to do problems and work on I'll bring those though, so you won't have to do those. If you have a laptop or a tablet you'd like to draw on, I'll upload those worksheets to Canvas so you can download it and do all that work on there. I'll be honest, when I took OCHEM, my professor did notes on the board and handouts, and material got lost, you know? So you might want to try to work out a way to keep those worksheets related to the pages in your notebook that they go with. Maybe on the worksheet you say notebook page this through this, or vice versa. In the notebook you say look at worksheet number, and then you number the worksheets. I used to have PowerPoint slides that I would do a lot of. And so you'll find these, no, sorry, those are my learning objectives, which I started doing last fall for the first time. These learning objectives kind of put to words what I want you to be able to do at the end of the unit. And you'll notice that these are like pretty directly questioned on the unit tests. But you'll notice in these modules that I have these lecture slides. You won't notice it right now because the course is blank. In the past, I used to just have these up, but they started like distracting me while I was teaching, so I stopped putting them up as often. And students used to download them and take all their notes from the board and put them right on here. You could still do that, but I don't always orient my lectures the way that these are oriented, so there might be weird gaps or disorganized things. But these are available to you. I have students that go through these. Do you remember earlier when I said that I used to make all of my own homework? Wouldn't that be such a good study tool for you? Extra practice problems written by me? Well, I didn't just write homework, I would write supplemental homework too, so that if students got stuck on the homework, they could go do the supplemental homework and see the answer key. So you actually have 2 sets of practice homework sets that you can do. You go down into the old 2310 materials. Here are some old PowerPoint slides. Oh, I used to do lecture notes slides, but I also used to do very detailed PowerPoint slides. God, I'm glad I stopped doing that. And then beneath them, old supplemental work and their keys, old homework and their keys. So you have tons of practice problems. None of them are graded. And you have the answers for them. I have to admit, though, there are errors on some of them that I just never got to correcting because I stopped using them. And sometimes the errors are on the answer key, which is very confusing. So if you ever have questions on these homework problems, just bring them to me. We'll talk about them. And they don't always line up perfectly with what's on active. I revised my course a year and a half ago, and these were before that revision. So there's a bit of a disconnect between these and those. But really, just go through and find what you need. Find what you want to practice. Ignore the rest. Does that answer your question? Great. Yes? No, that's for me. No, I'm sorry. Yes. 2 places. Sorry, I don't know where I am. 2 courses, 2 places that you will find my lecture material. YouTube is one of them. I have been taking these videos and just posting them to YouTube, just plain. That can be useful because you can zoom in on YouTube and you can see the board a little bit better, but you can also control the timing better. You might get ads though, sorry. The other place is right here on the home page. I'll have a link that says class recordings, and I'll upload week by week our videos here. You can also find my summer OCHEM 1 lectures, my fall OCHEM 1 lectures, as well as my fall Gen Chem 1 lectures and my OChem 2 lectures on YouTube. I'll be honest, I kind of ad-lib my lectures a little bit. We just like go with the flow. So if you didn't quite get something from this lecture, you could go back to a previous semester, find a similar concept, and you'll hear me say the exact same thing with different words and different examples. And that's because I find these definitions aren't super rigid. They're allowed to be flexible. And so I say them different depending on, I don't know, the vibes. So does that work for you? 2 different places, Canvas and YouTube. All right. Other questions? No? All right, I got to make sure that this course published because this sucks. Oh, I see. I copied itself into itself. I copied the wrong course. I went all the way to the bottom. Well, the bottom is spring. All right, I'm sorry. Here we go. Trying it one more time. That's why it went so quick. Okay. Some of you know the answers to this because you maybe have seen my lecture videos or have been in my class before. So somebody who doesn't know, what are the 4 fundamental forces? Ever heard of them? I mean, it seems like something you should learn, right? If they're called the fundamental forces. Nobody ever told you them before? You guys don't find yourselves in those YouTube rabbit holes like I do? You will. The 4 fundamental forces, these are generally the 4 forces that govern matter as we know it, the universe as we know it. The weakest and arguably not one of the fundamental forces. Oh, sorry. You guys have those little sheets. Could you pass them towards the very empty cabinets except for Nikola Tesla? The weakest force, and arguably not a force, is gravity. You all know gravity. You know it intimately. It's holding you in your seats right now. Gravity is felt like a force. It's experienced like most other forces, but it's arguably not a force. Newton says that the Earth is pulling on you, and you are also pulling on the Earth a little bit. But Einstein says the Earth is warping space-time. You are also warping space-time a little bit. And now you are moving in a straight line through space-time, which happens to be towards the center of the Earth, where space-time is narrowing. Can you give me an example of something that experiences gravity? Be as specific as you want, or generic.
A plane flying through the air, even though it's like it's going, I don't know.
A plane.
Like a satellite.
A satellite. True.
Something that still is in the air, but
Big
it's
things.
falling,
Things in the air,
but it's like moving.
in free fall, experience gravity.
Everything.
Everything. Good answer. Let's just get there. Can you tell me what everything has in common? Made of matter, has mass. Now, can you give me the fundamentals of those things that have matter, have mass? What are the smallest things that we know of that build up mass and matter? Rachel? Particles. Can we be more specific? Atoms, can we be more specific? There we go. Protons, electrons, and neutrons. We're not going to write protons and neutrons very often, but those are ways of representing them. What am I representing about protons, electrons, and neutrons with that little symbol that they have? Their charge. Listen, I bring this up because I've had students get halfway through OCHEM and tell me, oh, when I see a positive charge, I think of an electron. Yikes. That's something we got to address. So protons positive, electrons negative. We're going to deal with a lot of electrons. Pretty much all of the chemistry that we cover in general chemistry and organic chemistry, it's all about the electrons. In fact, I used to call my first lecture that. It's all about the electrons. Is that it? Things with mass, they experience gravity. You guys hear about the James Webb Space Telescope? All the cool things that it's finding out in space. These space telescopes will look out and they'll see a galaxy in more than one place. They'll see the exact same galaxy show up in multiple places in space. And it happens because of gravitational lensing. A galaxy emits light behind a very dense galaxy, and that galaxy warps the light from the other galaxy, and it warps it in more than one way. So we end up seeing images of this galaxy in more than one place because its light was warped by gravity. So it's not just everything with mass. Light experiences gravity as well, and famously, light has no mass. So, ergo, gravity really can't be a force between objects with mass if light is impacted by gravity, right? So it's not a force, but we think of it as one of the four fundamental forces. We certainly experience it, and it feels like it exists. That's good enough for me. All right, I want to talk about some other things then. Let's talk about the strong nuclear force. As the name implies, this is a force experienced in the nuclei of atoms, and it's very strong. This is the strongest of the four fundamental forces. This is what gives way to the nucleus. Plural of nucleus is nuclei. And so I want to take a second to talk a little bit about nuclei. This is where we see differences in nuclei within the same element. For instance, H1, the hydrogen nucleus, one proton, no neutrons, and since we're talking about a nucleus, electrons aren't really to be mentioned here either. Nuclei sit in the electrons sit in the electron cloud. But if I take that one proton and I add to it a neutron, I get the isotope deuterium, which is hydrogen, but now it has both a proton and a neutron in its nucleus. That proton and neutron are held together by the strong nuclear force. The reason the proton and neutron don't fly apart is because of the strong nuclear force. Carbon 12 compared to carbon 13. How many protons in carbon 12? 6. How many protons in carbon 13? also 6. That's our definition of the element, is the number of protons in its nucleus. How many neutrons in carbon-12? 6. And how many neutrons in carbon-13? 1 more than in carbon-12. 7 neutrons in carbon-13. Cool. We're going to deal a little bit with carbon-12 and carbon-13 this semester, so I want to bring this up. But as a reminder, the strong nuclear force is essentially what's responsible for isotopes, not I5-topes. Isotopes exist because the strong nuclear force exists. Different amounts of protons and neutrons can be held together. The weak nuclear force is the second weakest nuclear force, and this is the least relevant to us. This has something to do with things inside of protons and neutrons. For instance, when nitrogen 14 gets hit by radiation, it turns into carbon-14. If you've heard of carbon dating, it means you're looking for the amount of carbon-14 in a sample. Carbon-14 is generated in a sample because of exposure to cosmic radiation, just radiation that makes it through the atmosphere. So that has something to do with keeping the same number of neutrons and protons in total, but changing one of the 7 protons in nitrogen. Changing one of the 7 protons in nitrogen into a neutron, thereby changing the number of protons to 6, but keeping the mass the same. So that has something to do with the strong nuclear force within the proton and neutron itself. The weak nuclear force. Okay, now the last part, electromagnetism, which I have not left myself enough time for, is what you're all holding in your hands right now. And it's what governs everything you've learned about in chemistry before this class and everything about chemistry in this class. So if you would take your magnets and try to hold those opposite ends apart. Try to hold those magnets away from each other. If you didn't get a magnet, maybe someone next to you will help share with you. Do you feel that force? Is that electro or is that magnetism? Which part of electromagnetism are we dealing with there? Feels like a magnet. What are those magnets made up of? Atoms. What are those atoms made up of? Electrons. And those electrons are the source of the magnetism. We call this force one thing despite 2 different experiences that we feel. If you charge your phone at night, you're using the electric force to pump electricity into your phone. Right now, all you're feeling is the magnetic force, but those are just 2 versions of the same thing, 2 different experiences of the same force. Here's some really cool applications. When an electron spins, the movement of that charged particle induces a magnetic field. So if you can make an electron spin, it already does that on its own, you have a magnet. The nature of having that electric charge creates the possibility for magnetism. And if your electron spins the other way, your magnetic field flips the opposite direction. You guys have heard of electron pairs? Why do electrons come close to each other if we know that like charges repel? Because they're not just like charges, they're also magnets. So this is the magnetic side of it. We also, again, recognize that like charges should repel each other. Just like on magnets, how like sides of a magnet repel each other. I want you to flip your magnets. I want you to feel that repulsive force. Push the like ends of your magnet together. Try to get them close. You'll feel them slip past each other. Opposite ends of a magnet attract, just like opposite ends of charges attract. Electrons are drawn to protons. Have you ever wondered why electrons and protons never collide? If they're attracted to each other like magnets, then why don't they ever come together? Well, they do in the birth of neutron stars, so it's not a pretty thing. But this is what gives us our electron cloud. The nucleus sits here in the middle, and the electrons keep trying to come in to find that positive center. Electrons are very tiny, essentially have no mass. Nuclei are very tiny, but essentially have all the mass. The electron clouds are enormous. If an atom were the size of the state of Colorado, the nucleus would be the size of a baseball. So you've got electrons whizzing around Colorado looking for a baseball at CU's stadium. Are they ever going to find it? Probably not. But they're pulled in by that electromagnetic force. That same force that you are feeling in your hands right now is the force that the electrons feel towards the proton, is the same force that electrons feel towards each other, is the same force that atoms feel towards each other when they come in and bond. They have some repulsion, they have some attraction, and they stabilize somewhere in the middle between that attraction and that repulsion. Everything that we talk about this semester is just an application of magnets. Some are very weak magnets. You guys ever had that magnet you stick on your fridge and it just slides to the ground? Not a very strong magnet. Some atoms are like that. They're very weak magnets. They don't interact with other magnets. You guys ever had a magnet you can't possibly get off of your fridge because it's too strong? Some atoms are like that, very strong magnets. Everything that we deal with is really just magnets with special names and special qualities. So I want you to ingrain this feeling right now, that attractive force that you can't quite stop, and that repulsive force that you can't quite overcome. And I want you to recognize that that's chemistry, all the way down. Okay, thank you guys for letting me go over. Thank you for your time. I will see you Wednesday for our first real lecture on section 1. Try to get that pre-reading quiz done before you come in. Thank you. Have a good night.